Now let's know some of the drawbacks of the wireless networks and answer some of the review questions over these two sections. The wireless network's drawbacks lies in the limitations in the coverage. The areas covered by the wireless network is obstructed by walls and long distances, and sometimes weather conditions such as in satellite communications and things like this. So walls can obstruct the signals and can cause attenuation and can cause reflection and refraction for the wireless signals. Long distances can cause very strong attenuation for the wireless signal and may make it very weak to be heard correctly and to be utilized at the end device. The weather conditions can act as a weakening for the wireless signal as well, and reflection and such conditions can be obvious in the satellite communication. The wireless network generally has a higher bit error rate, higher than the corresponding wire network. Wireless is in general less in the security features. This is because the communication media is the air. It is open for sniffing. It is susceptible to any listening device that can catch the signal intended from a certain sending device to a certain receiving device and interpret it and know its content, because it is just in the air which is open for everyone. So sniffing is probable, very highly probable. Sometimes the wireless network is very costly in charging, like the GSM, like the USB modem, which uses the GSM network. So it depends on your subscription. Either you are monthly subscribed or you pay as you go, so it can be costly than the wired network. It cannot fully replace the wired infrastructure. The wireless network is to serve the mobility and the flexibility goals only, but it is hard and very rare to find a network that is completely wireless. Even the mobile network, the mobile operator network, is wireless only in the access network, but it is wired in the core. Many networks act like this. It is wireless at the access sides to offer mobility and flexibility, but it is wired in the core to connect and to communicate between the fixed devices, the fixed connecting devices forming this network. Now let's have some review questions. What is the standard protocol over the internet? It's the TCP/IP protocol. What does TCP/IP stand for? TCP/IP stands for Transmission Control Protocol, Internet Protocol. Many people studies this protocol and ignores knowing the meaning and knowing what does it stand for. And let's figure out here that the TCP/IP, the word of the protocol suite, is composed of the two most important protocols forming it, the TCP protocol in layer 4 and the IP protocol in layer 3, the network layer. What are the layers of the TCP/IP? It's application, transport, internet or networking, and network access. As you can see, only 4 layers. It is not like the OSI composed of 7 layers. Some names are common, like the application, transport, internet or network, and some names are not common, like the network access. Let's recall here that the network access is formed of the physical and data link layers of the ISO OSI. The internet is the same as the network layer. The transport is the same as the transport layer in both in the OSI model. The application here in the TCP/IP is corresponding to 3 layers in the OSI model: the application, the presentation, and the session. Layer 7 and layer 6 and layer 5 in the ISO OSI model are here corresponding to 1 layer in the TCP/IP, which is called the application layer. This is very important to recall. Name some of the application layer protocols in TCP/IP. We can name several protocols working in the application layer of the TCP/IP, such as the HTTP, Hypertext Transfer Protocol, the FTP, the File Transfer Protocol, the DNS, the Domain Name System Protocol, and the SMTP, the Simple Mail Transfer Protocols. All of these are working in the application layer of the TCP/IP. Let's here recall that the application layer of the TCP/IP is corresponding to three layers of the ISO-OSI model, which are application, presentation, and session. What are the port numbers used by each of the above protocols respectively? Let's recall here that HTTP uses port number 80, FTP uses port number 21, DNS uses port number 53, and it can act either TCP or UDP. SMTP uses port number 25. These port numbers are identifiers that exist in the transport layer that identifies the type of service requested from the client to the server to identify the type of data that needs to be transmitted between both machines. HTTP transfers text, images, and hypertext. FTP transfers files. DNS transfers domain name queries and reply to resolve between IP addresses and domain names. SMTP is for the exchange of emails between the mail servers and between the mail servers and email clients. What is the length of the IP address in bits? What is the length of the IP addresses? It's 32 bits in version 4 and 128 bits in version 6. This is the length of the IP address. Let's recall here that the IP address is a unique identifier, logical identifier, bound to the geographical location of the machine. What are the devices working in layer 3, or what could be the devices working in layer 3? The router is the most common device working in layer 3, and layer 3 switches are another type of devices working in layer 3. Layer 3 switches are somehow faster. It uses the hardware to perform the routing function. How can the routing table build inside the router? It can be built either statically by the admin, entered by the admin of the network into the router, or the router can build it dynamically through some routing protocols that acts dynamically, through some dynamic routing protocols such as the Routing Information Protocol RIP or Open Shortest Path First protocol, which is OSPF, and other protocols that can act dynamically to build the routing table inside the router. What are the main advantages of a wireless network? Many advantages of wireless: flexibility, mobility, scalability, and other advantages for the wireless network over the wired. But let's remember here that the network can be composed of mixed technologies, wired and wireless. Wireless to offer flexibility, mobility, and scalability, and wired to connect this wireless network to the wired infrastructure. In which layer does the WAP work? The WAP is the wireless access point. It works in layer 2, the data link layer. It works in both layers, the physical and the data link, but it is a layer 2 device. What are the main drawbacks of wireless networks? We had some drawbacks. Its limitations in the coverage area due to the obstacles of walls or weather conditions, or sometimes the long distances that can attenuate the signal being transmitted. The sniffing, it's a security vulnerability in the wireless networks. It allows for sniffing of the data being sent from the sender to the receiver, because the transmission media is open for everyone. It is simply the air that can be sniffed by anyone, and the message that is intended to a certain recipient can be interpreted and received by another recipient that was not intended. This is of course a security hole or a vulnerability. The wireless networks in general have higher bit error rate than the wired ones. And by this we come to the end of our wireless section. Hopefully we have briefed many of the wireless concepts. Thank you.